Good afternoon, everybody, and welcome. My name is Beth Strausser, and I work in the policy office at the National Science Foundation. So it is my pleasure to welcome you today to the Fall 2023 NSF Virtual Grants Conference. This is the third day of the conference. So I am now pleased to present this session, which will cover programs in the Engineering Directorate. And this session will be presented by my good friend, Dr. Prakash Balan. So take it away, Prakash.
Thank you, Beth. And hello, everyone. We're really delighted that you have joined this session and are spending the next hour with us, hearing about what we have to share with you. So let me share my screen here. All right. So we're going to share information today about the NSF's Directorate for Engineering and the numerous programs that we have in the Directorate that are really aimed at helping you put your best ideas forward and have NSF look at them and consider them. So let's take a really high-level view of NSF. And NSF is set up with a very broad vision. Its vision is really a nation that leads the world in science, engineering, research, and innovation to the benefit of all without barriers to participation. So NSF is organized into these broad directorates, each with a very wide focus. And they are in all fields in science and engineering, computer science, engineering, geosciences, the biological sciences, education, the mathematical and physical sciences, the social, behavioral, and economic sciences. And we also have cross-cutting offices that are focused on integrative activities, as well as international science and engineering. And last but not the least, we also have a brand new directorate at NSF called the Directorate for Technology, Innovation, and Partnerships. And the TIP Directorate really is aimed at driving NSF's investments in fundamental research in all fields in science and engineering towards further downstream translational impacts to really benefit society. So, NSF over the years has had major contributions to our nation. We have funded over 260 Nobel laureates. We have numerous successful startups that have been supported by NSF that have had seminal advances in a variety of fields. We have moved whole new fields such as 3D printing. We helped us fund the internet in a very significant way. And technologies like GPS and MRI are all products of the hard work that NSF-funded researchers have been able to achieve. So if you take another view of NSF from a funding perspective, academic institutions in the most recent science and engineering survey spent close to $100 billion in research and development funding in FY22, and about 55% of that was from federal sources. If you look at NSF's contribution to research in a wide range of fields, you can see it right on this chart. It's very substantial. And if we zero in on engineering specifically, NSF funds 44% of federal funding for academic basic research in the wide world of engineering. So it's quite a substantial funding impact in the US. So at the heart of all of this is you. We are trying to create opportunities that cover scale, breadth, career stage, and the full innovation cycle. You could be an individual investigator or in a large multifaceted team. And NSF's range really covers single and multiple disciplines, offers a spectrum of ways in which you can engage, whether you're an undergraduate, graduate student, postdoc, or even a professional researcher, and at different stages in your professional career. Your work could span the full range of activities from fundamental research, curiosity-driven research, to use-inspired research, as well as research that spans the whole translational pathway from basic research to commercialization to generate downstream societal impact. If we take a look at the engineering directorate in NSF more specifically, this is how it's organized. In general, at NSF, directorates are the big blocks that cover very vast areas. And within those directorates, we have smaller subdivisions called, they're basically called divisions. And within the engineering directorate, we have 4 key divisions. And we have an office, which is the Emerging Frontiers and Multidisciplinary Activities Office. You'll also notice that these divisions cover the whole breadth of the world of engineering. And within each of these, we have what are called clusters. These clusters house the core research funding programs. And in many ways, these clusters represent today's snapshots of what the nation's research community is actively engaged in. And if you were to come back 10 years from now or 20 years from now, these cluster names might be different. So if you look at the CBET division, the Chemical, Bioengineering, Environmental, and Transport division, it has 4 clusters. The Civil, Mechanical, and Manufacturing Innovation division, often fondly called CMMI, it has 5 broad clusters. The ECCS division, or the Electrical Communication Cyber Systems, has 3 major clusters. And then the Engineering Education and Centers division has 4 clusters. So keep these clusters in mind as you're thinking about programs, you're trying to figure out who to go talk to, reach out to the appropriate division and zero in on the cluster that might be closest to your research topic. And definitely that's a great way to start a conversation. Engineering by the numbers for fiscal year 2023, and our fiscal years run from October of a given year to September of the following year. So fiscal year 2023 ended in September. And these are our high-level statistics. Let me zero in on a key aspect of these statistics here, and that is really about the people. In this recently completed fiscal year, we had over 22,000 people touched by new NSF awards across 312 institutions. And over 55% of those were students. And if you looked at the composition of those that student population, about 60% were graduate students and 40% were undergraduates. Now, to support this extraordinarily vast range of activity at NSF, we have 152 staff, and we have 60 program directors in the engineering directorate that really drive the mission of this directorate. Our strategic plan is entirely focused on you. We have numerous opportunities, and we really want to seek to transform the world for a better tomorrow. In many ways, we want to propel leadership in transformative engineering. We want to expand opportunities, and we really want to catalyze powerful and impactful partnerships. We have several key goals, and I'm going to focus on each of our key goals in this talk. The first goal really is to propel US leadership in transformational engineering approaches to problems with significant societal impact. And so over the next few slides, I'm going to go through a kaleidoscope of potential funding opportunities that are supported by the engineering directorate. And if you spot programs that are of strong interest to you, please note down the funding announcement number, because it is something that you can easily web search and zero in very quickly on the specific funding opportunity and then research it a little more. So the engineering directorate really is set up with programs that have 4 broad research themes. So if you look at the pillars, the verticals, those are the broad research themes, and they are, we recognize that broadening participation, equity and justice and access, sustainability and resilience, and partnerships for translation are all necessary to achieve significant progress. And we actively seek to coordinate, collaborate, and co-fund ideas in all of these areas. Let's take a look at the first one. On those cross-cutting themes that we had on the previous slide, clean energy is an enormously important topic in the Engineering Directorate and at NSF more broadly. One of the first strategic priorities for engineering in the clean energy space is captured in announcement 23108, which really is calling for conference and research proposals to identify collaborative research opportunities to advance science, technology, and clean energy. Now, the topics are listed further down on this chart, so take a look at those key broad topics. And we also have NSF 23109, and please note, every NSF announcement will have NSF followed by a number. So that is the magic data that you need to do a web search to find the opportunity in the future. So write those numbers down if something really excites you. So 23109 is really encouraging raise and eager proposals that pursue the topics further down. Now, keep in mind, a raise is the type of proposal that may be used to support bold interdisciplinary projects. And it's a powerful way to propose such projects to NSF. The eager is a type of proposal to support what we call exploratory work, early stage, untested, but potentially transformative research ideas. We would put those ideas in what we call the high risk, high reward category. And there's a lot more information available on all of these proposal types in the NSF's proposal and policy procedures guide. So it's called the PAPPG. And we'll be mentioning that several times through this presentation. Now, we have another very powerful and broad opportunity published in NSF 21124. It's called commonly called the CAS DCL. DCL is a Dear Colleague letter. It's a type of announcement where we encourage submissions to existing programs and also talk about maybe supplemental funding opportunities and such. So the critical aspects of sustainability, the CAS Dear Colleague letter, really encourages you to explore a variety of opportunities. You could organize a conference, a workshop. You could explore a partnership with industry via a GOLI proposal. I'll talk a little more about what GOLI is all about later in this talk. You might want to do a partnership with a small business via the Small Business Innovation Research Program, the SBIR program. Or for that matter, you might want to submit a standard research proposal to explore more fundamental research challenges via many of the core programs that are available in the Directorate. You could also submit eager or raise proposals to NSF. And what is nice about this opportunity is it is encouraging these submissions on a rolling basis. And so if you're interested in submitting, read the DCL and take the next step. All right. Now, on the topic of clean energy, there are two other key initiatives that I highlight on this slide. So the CBET division, which I described earlier in this talk, has the fluid dynamics program, and there is a powerful partnership that has been created with the Department of Energy in the Wind Energy Technologies Office. And there is a special opportunity for you to submit proposals to the Fluid Dynamics program, pursuing ideas in wind and ocean energy harvesting, and submissions are accepted at any time. There is another really powerful opportunity, and this is focused on workforce development in the green energy, the geothermal energy space, and it's through the intern program. I'll have a lot more to say about the intern program later in this talk. And so just keep this in mind. These are unique opportunities in the clean energy space that are currently active at NSF within the Engineering Directorate. We also have additional opportunities related to climate change and adaptation and mitigation. And the first opportunity here, again, is encouraging eager proposals. As I said before, eager is early concept grants for exploratory research, and really is high risk, high payoff submissions. And these are internally reviewed at NSF by multiple program directors. So it's a fast moving way to get an idea off the ground and get support at NSF. The second opportunity is for planning proposals, which is again a kind of proposal that is used to support initial conceptualization, planning, and collaboration activities that aim to formulate new plans for larger scale projects. So a planning grant is a smaller grant, but it gives you a lot of opportunity to do the initial exploratory work before you propose something more substantial. Switching gears, the NSF Engineering Directorate also has opportunities where you can explore research infrastructure. In many ways, think of there is a very strong and ever-present need for infrastructure that is diverse in space, cost, and implementation time, everything from major observatories to nationwide sensor networks to smaller experiments. And there are many important potential facilities that fall between these boundaries. There is definitely a gap between very large investments and smaller investments. And this mid-scale research infrastructure program really helps to bridge that gap between projects that are in the, let's say, the $6 to $100 million range, all right? So the mid-scale research track one supports implementation of infrastructure, which typically is under $20 million, and the mid-scale RI2 is between $20 and $100 million. Now, NSF Engineering has also made significant investments in the past in infrastructure through the Nanotechnology Coordinated Infrastructure Initiative, as well as the Natural Hazards Engineering Research Infrastructure Initiative. Both these initiatives have had major investments nationwide that impact both those broad topic areas. So if you want to learn more about these programs, visit the websites, and there's a wealth of information available there for you to review. Now, if you look at the bioeconomy space, which is another broad area which the Engineering Directorate impacts, the opportunities on this slide really are sampling of programs in biotechnology research. The Emerging Frontiers in Research and Innovations program has a new opportunity at the intersection of biotechnology and artificial intelligence. And we have submission due dates that are in January of 2024. So keep that in mind. We have another opportunity further below that encourages transformative research for bio-inspired design. Think of it as research that is aimed at discovering the general principles about biological and engineering systems and ways to use them to inform and generate new design directions for engineered systems and products. And the opportunities for the submissions to that program, NSF 23055, are really supported broadly by the Engineering Directorate, the Biological Sciences Directorate, and the program called the Partnerships for Innovation program in the TIP Directorate. So we have an ever-present need for the capabilities to sense and to respond to unknown and known biological threats. And so NSF DCL 22077 is an announcement that encourages research to address these societal challenges, and submissions can be made at any time. DCL 2277 is led by the CPET Directorate, and within the Biological Sciences Directorate, it's the Molecular Cell Biology Division. Another major program in the Engineering Directorate that supports fundamental research and education of a future workforce to overcome scientific, technological, education, economic, social barriers is the Future Manufacturing Program. It has two tracks. It has a seed grant track, which is typically about $500,000 award for 2 years to promote the formation of new teams, explore new ideas, concepts, and there's really no preliminary data required to submit to that. So if you think of future manufacturing as a way to pursue ideas in manufacturing that don't exist at scale today, you really need to do the upfront work to generate these new innovative approaches to seed manufacturing of the future. So I said earlier, there are seed grants available. There are also broader, bigger research grants available through this program. Those grants are typically about $3 million over 4 years. Think of those submissions as being aimed at broader, more ambitious proposals, and you need a multidisciplinary, broader team to really support that. Now, in the most recently completed fiscal year, FY 2023, the Future Manufacturing Program has invested $35 million in 21 projects. There is a sister opportunity, which is directly related to the challenges of the manufacturing sector, and that is related to next generation supply chains. We may have all read in the news how the COVID-19 pandemic led to major dislocations in global supply and demand. There were significant vulnerabilities that were exposed in almost every supply chain. And this Dear Colleague letter really is an attempt by NSF to help fund research to significantly advance our understanding of global supply chains, especially their ability to provide industrial goods, critical healthcare, medical products, consumer products, and key services robustly over a wide range of operating conditions and potential disruptions, and how to handle those disruptions and how to handle emerging threats. So it's a powerful opportunity. If you're in this space and you're looking to do research, then the next generation supply chains Dear Colleague letter is definitely worth a read. Microelectronics is a big focus at NSF. What I have on this slide are a few more opportunities that are aimed at semiconductor fabrication. And think of DCL 22113 as funding that is aimed at or encouraging submissions that are aimed at supporting fabrication of research devices and systems through standard semiconductor fab facilities. So it really gives you access to that. And 22636, the program on the further below, on advanced chip engineering, design, and fabrication, it's really aimed at helping the nation accelerate discoveries and innovation in semiconductor research. The focus being overcoming chip design and fabrication barriers, and also doing it with international partnerships. So a proposal to that funding opportunity must describe an integrated collaborative effort between the US and researchers in Taiwan, focusing on bringing a specific innovation to integrated circuit prototypes. So think of it from that perspective as you look at that opportunity. Also, in this rapidly emerging area of quantum technologies, the whole broad spectrum of quantum information science and technology is a major priority for the United States. DCL 22077 is an opportunity for submissions of eagers as well as standard research proposals. And the focus there is really on new manufacturing innovations, enabling and accelerating the manufacture of quantum devices, with an emphasis spanning from device fabrication to potential modes of system integration. So think of it from that perspective. The next funding opportunity really is expanding capacity in quantum information science and engineering. So 23551, $38 million from across NSF and 22 projects were invested in 2023, in fiscal year 2023. And this program really helps build and maintain a close connection between new efforts, as well as existing impactful work in research research training, education, outreach, and broadening participation in the broad world of quantum information science and engineering. Further down, we also have the open opportunity. Well, I guess the deadline just closed recently. NSF 23604, which is focused on the Quantum Virtual Lab Initiative. All right. Now let's switch gears and talk about another major goal of the Engineering Directorate, which is expanding opportunities for people. Within the Engineering Directorate and in the Division of Engineering Education and Centers is housed the Broadening Participation Engineering Program. And through this program, NSF is really trying to seek to strengthen the future of US engineering workforce by enabling and encouraging the participation of all citizens in the engineering enterprise. So we really want to be very inclusive in the world of engineering and engineering education. And through the funding opportunity 22514, a variety of opportunities are being offered through 4 separate tracks. So each of the bullets on the slide is a track. And track 1 is planning and conference grants accepted at any time. Track 2 is research and broadening participation. Track 3 is inclusive mentoring hubs. And what we call an IM hub. An IM hub is expected to offer free access to mentoring and networking opportunities, provide professional development programs for members who participate in them, and also coordinate institutional and organizational involvement to expand these mentoring programs. So an IM hub activity could include participation in curriculum-based modules, focused on engineering as a career, grant writing, entrepreneurship. It could even be transitioning between academia and industry, and also maybe mentor-mentee training and skills. And the final track is Centers for Equity in Engineering. Both the inclusive hubs and the Centers for Equity in Engineering both have target dates of the 3rd Wednesday in November. Folks, keep in mind, target date is not a deadline. So keep that in mind. Target date has a very special meaning at NSF. It means that submissions should generally come in around the target date, but if you come in after the target date, the submission will still be accepted. Although if you come in too much after the target date, you might miss the panel that has been planned for the proposals, but we will still accept your proposal. So hope this gives you a sense for the spectrum of opportunities that we have to broaden participation in engineering. Another really exciting program within the Division of Engineering Education and Centers is the Revolutionizing Engineering Departments program. And it really is a program that has multiple tracks. It's called RED for simplicity. We love our acronyms, so we made up another acronym for that. So RED Innovation, we have RED Adaptation and Implementation, and then we have RED 2-year. The current, the latest, most recent opportunity has been in the RED 2-year program. And it's really, the RED program is to develop revolutionary changes in education, in the education of a new generation of engineers. You know, you can literally innovate on a wide spectrum of educational designs, curricula, ways to teach engineering, and really reinvent in very creative ways how it is all done. And NSF 23553, it focuses on what is called RED 2-year, 2-year signifying 2-year institutes of higher education, typically community colleges and technical colleges. And the program that RED 2-year really is to develop radically new approaches for multiple 2-year institutions to expand the path to engineering and engineering technology 4-year programs. So going from a 2-year program to a 4-year program, it really helps you create new creative pathways to make that happen. There is an excellent recorded webinar on the RED website. The link is on the slide. So when you get the slides, go to, if you're interested in this program, go online and take a look at that excellent webinar. It's very informative. NSF also offers a lot of early career support for postdocs. There is a fellowship program. Follow the link on the slide and contact the efellows.asce.org website for more information on that. There is a program called Engineering Research Initiation. Right now, proposals are under review. It is aimed at really helping investigators who have never received federal agency funding from non-R1 universities to really get access to funding opportunities through NSF. And finally, last but not the least, is the faculty early career development program called the Career Program, which many of you might be very familiar with. It's a foundation-wide activity that offers NSF's most prestigious awards in support of early career faculty who have the potential to serve as academic role models in research and education, and to lead advances in the mission of their academic departments or institutions. So career awards are highly prestigious, and there are also workshops, proposal writing workshops for that program. Take a look at 22586, which has a deadline of July 24th, 2024 for that program. NSF and engineering, we have a lot of very exciting workforce development programs. So that's what I'm going to start describing in the next few slides. The REU program is focused on undergraduates to create both sites at institutions that can have cohorts of undergraduates work on exciting research projects over the summers, as well as the opportunity for individual awardees to ask for supplements to bring undergraduates into their NSF-funded work. So REU is a great way to get undergraduates exposed to your ongoing NSF funding, NSF-funded research, and inspire them to pursue research, or at least learn about how research is done as they graduate and move into professional careers. The RET program is focused on teachers, similar objectives to inspire teachers through these research opportunities to both enrich themselves as well as give back through their institutions to their students. We have special opportunities for veterans to re-engage in research at all levels, undergraduates, graduate students, and teachers. We have a wonderful new program called START, Skills Training in Advanced Research and Technology. That's what START stands for. It's aimed at community college students so that they can get traineeships at NSF-funded engineering research centers, which is a major investment, which I'll talk about a little later in this talk, as well as the IUCRC Industry University Cooperative Research Centers. So it's opportunities for community college students and faculty to get traineeships in these centers. The REM program is a powerful program for mentorship of a cohort of high school students, teachers, as well as undergraduates, faculty, and veterans, and they accept proposals in a window between August and November each year. And last but not the least is the intern program, which is NSF's flagship program aimed at offering graduate students the opportunity to get professional training while they're in graduate school. And I'll be speaking a whole lot more about that in the next few slides. So let's talk about those graduate students. Today's job market for graduate students, NSF statistics says that 57% of our PhDs and 81% of our masters start careers in non-academic jobs. They're not going to be starting as faculty, but they're probably going to be going beyond the academic training environment that they were educated in. If you look at engineering PhDs, that number goes way up. So 83% of PhD engineers start their careers in industry or government. Now, NSF at any given time has over 40,000 graduate students that are supported on NSF grants. So we felt there was a very strong need for NSF to do something to really prepare these students for professional careers. And that's what led to the creation of the intern program, to help better prepare NSF-supported graduate students for professional careers. the aim of the program is to give them immersive exposure to hard and soft skills. So when I say hard skills, that is science and engineering. Soft skills is everything else that you need to be a successful professional. And this chart pretty much covers that entire spectrum, which is the sweet spot for the intern program. Technical skills, entrepreneurship, business thinking, working in diverse themes, project management, communication, science communication, talking about your work, all of that is so critical to succeeding as a professional. And so if you look at the benefits of the intern program, it gives graduate students real-world immersion and learning. For the hosts, it really gives them access to a new generation of talent. For NSF, it catalyzes workforce development. And for universities, in many ways, it builds new, stronger links with industry and government. So a student goes off and does an internship at a host organization. That's step one. A relationship builds. The student is finished, moves on. But the relationship with the PI's research team continues. There can be significant growth in that relationship, and ultimately, the institution benefits from that overall growing relationship. Here's a quick summary of the kind of host organizations that a student can use the intern program to pursue a traineeship. It could be small business, startups, it could be government agencies, it could be national labs, it could be industrial labs, small, medium, and large, policy think tanks, science centers, etc. So let's dive a little more into this supplement. It's $55,000 for up to 6 months at an internship host. International students are certainly welcome to participate in this program. Funding is for a variety of very important costs that any student is going to have to deal with. And so the supplement really provides 100% coverage for all the costs that a student or a PI may have to incur in supporting this activity. We support over 250 interns a year, typically, and there's an intellectual property agreement that is required between the university and the host organization, and NSF is not a party to that. So the whole idea is to do some pre-flight planning, because it's quite possible the student could come up with something creative in this research project, and which could lead to intellectual property creation. And we have seen instances of that happening from the students that we have supported to date. The intern program is seeing very strong interest from other agencies. So I just give you a list of all the different DCLs that we have. 21013 is the mothership in many ways. That is a broad intern DCL. 21029 is really opportunities specifically at the Air Force, at their Air Force Research Lab. 23024 is really aimed at, it's a partnership with the DOE for students to get trained in geothermal energy as a broad sector. And keep an eye out on the website that I put on this page for other future announcements relative to the intern program. Okay, another major goal within the engineering directorate really is to catalyze purposeful partnerships. And I mentioned the GOLI program earlier. This is GOLI on a slide. What I want to point out is the point of GOLI is it's a proposal type and not a program. So, which means you can submit a GOLI proposal to a lot of programs at NSF, both to existing solicitations as well as unsolicited proposals. The idea behind GOLI is for a researcher to build a partnership with a research-intensive industrial partner so that the basic research can then continue to translate down through that partnership into downstream societal impact. Typical GOLI proposals are 3 to 5 years, 100 to 150K a year. And what is new in 2023 is that the GOLI proposal can request for up to 1/3 of the budget to go to an eligible small business organization. So you could have small business partnerships where the industry partner is a small business, and they could be paid up to 1/3 of the budget for their scope of their research activities. If they're not an eligible small business, then no money can go to the industry partner, and that is the traditional GOLI model. But with 2023, this is greatly opened up to small business. And there's a lot of value propositions for everybody who's involved. For the faculty, it's building these partnerships, doing the research. For the students that are involved, they get get trained on real world problems. For industry, it's access to university and the faculty and the students and the talent. For NSF, we're really transforming through research collaborations. And for universities, it really builds long-term relationships also. Now, we have other investments that catalyze strong partnerships, and these are through the centers program. So in the division for engineering education centers, we have two major center types that the engineering directorate supports. The first one is the engineering research centers, which really is deep long-term investments that engineering makes in supporting very broad centers for up to 10 years of support. And since 1985 through 2023, these engineering research centers, are commonly called ERCs, have had some very major outputs. As you can see from that small inset table that I have on this chart, the impact of these centers has been quite substantial. And there is an ongoing competition right now for new potential ERC awards for 2024. We have 15 ERCs nationwide, and there are 42 unique institutions that are participating, and over 241 industrial participants in these centers. Okay, the other centers program that I want to talk about is the IUCRC program. The IUCRC program is Industry University Cooperative Research Centers, and really comes together through NSF catalyzed funding, where government, it could be other government agencies, universities which provide research infrastructure, human capital, and technical expertise, and industry that provides the research funding, for them to come together to form what I call IUCRCs, or these research consortia. And out of an IUCRC comes research that is really focused on bridging the gap between early stage academic fundamental research and commercial readiness. So there's a gap in between, and these centers help pursue research that is what we call use-inspired research. It is still pre-competitive. It is work that can get published in a thesis, papers, conferences, and such. But ultimately, that research drives downstream technological innovation within the organizations that are members. And we have a nationwide portfolio of centers, over 80 of them, over 120 universities participating, over 24 universities that are in EPSCoR states, 15 minority serving institutions. And we have over 800 member organizations, mostly industrial firms, and over 20 federal agencies that support IUCRCs nationwide. On an annual basis, NSF puts in roughly about $20 million, and the members, the industry, put in close to $60 million into this program. It's almost a 3-to-1 ratio on NSF money. And each year, 500 to 700 students who are trained at these centers graduate each year, and they enter the workforce. The centers have very broad research themes, as you can see on the slide. None of these are solicited. These are all what the community is bringing to us as the cutting edge developing emerging areas in the US economy. The program is wide open to transformative new ideas. And here are some examples of recently awarded centers in the engineering directorate. We made awards to one in the semiconductor chips sector, one in the quantum technology space, and one in a totally different area, in Center for Soil Technology, which is, we have to feed a growing world population, and we need innovations in the whole ag soil space, which will make that possible. And this center is all about that. The IUCRC model has 3 key players: NSF, that provides administrative and management costs, industry that provides research dollars, and the universities that really provide the infrastructure, the intellectual capital, and reduced indirects. The money is pooled, research projects are supported, and outcomes, innovation, a powerful skilled workforce, intellectual property, and startups. In fact, over the 2010 to 2020 timeframe, over 80 startups spun out of the IUCRCs nationwide. I wanted to give you a concrete example of a center. Here's one example. It's the Advanced Mammalian Biomanufacturing Center. It is run by 5 universities, but Johns Hopkins is a lead. You can see the kinds of organizations that are members of this center, highly recognizable companies in the biopharma space. And on an annual basis, this center gets $750,000 from NSF, and industry puts in $1.8 million annually. That gives you a sense of the leverage that each center generates. Okay, so I'm approaching the end of my talk. I have a few key takeaway messages for all of you. The first step, if you're looking to find out what's going on at NSF, what are the hot topics that are being funded, nothing better than having a search engine. And NSF has a shortcut link that you can remember. So you just go to nsf.gov/award search. You can also go explore funding opportunities at nsf.gov/funding. So look for funding opportunities that maybe you missed the email from NSF, maybe you're not subscribed to our updates, which I would highly recommend you do. You can still go to nsf.gov/funding to find those funding opportunities. We highly recommend contacting program directors at NSF early and seeking input. And as a first step, if you found a funding announcement and you want to learn more about it, we recommend you read the entire funding announcement a couple of times, and then reach out to the NSF program officers with more things to discuss. Maybe send a one-page white paper on what it is you want to discuss. And so it could be a very productive, fruitful discussion. You could definitely contribute your research and knowledge as a reviewer on NSF proposals. And we constantly are looking for reviewers to engage with NSF. We would love to have new people coming to NSF to review, in addition to those who may have reviewed in the past. And also, you may have great ideas for things that NSF ought to be thinking about. So please don't hesitate to write us and suggest new ideas and initiatives for programs that NSF should consider. If you wanted to volunteer to review engineering proposals, we have a QR code. You could just go to that website. You could fill out a very short survey, and then we will know of your interest, and then we'll reach out to you when the right opportunity comes up. Please subscribe to NSF News. At the least, it's a fantastic science news feed. It's free. And every week you can learn about exciting activities, innovations and discoveries that are happening in the world of science. You can also learn about funding opportunities. You can also find out about job opportunities at NSF. You can connect with the engineering directorate through the URL on the screen, nsf.gov engineering/connect, and reach out to us and stay in tune with what's happening, because when you get that bright idea, it's better to be pre-informed as to what that next step should be, so that you can move quickly. Just to summarize, the Engineering Directorate and NSF, we really seek to transform our world for a better tomorrow. We want to drive discovery. We want to inspire innovation. We want to enrich education and accelerate access. So thank you so much for your time at this webinar, listening to all these exciting opportunities. And at this point, I'd be happy to turn this back to Beth so that we can take your questions. Thank you.
Okay, great. Thank you so much, Prakash, for that fantastic, very informative presentation. Okay, so we do have a few minutes for some questions. We have a bunch that came in, so let's get right to it. So does computer software engineering belong in the division of engineering, or size, or both?
That's a great question. So it would depend on what it is you're trying to do. If what you're trying to do involves certain engineering concepts that the Engineering Directorate broadly supports, then there might be interest from programs within the Engineering Directorate to support the work. A good starting point would be to write to the program director that you believe is closest to your proposed work, both in the Engineering Directorate and the Computer Science Directorate, and solicit feedback, because they might be very well positioned to tell you how best to pursue your idea and what opportunities to submit your ideas to.
Okay, great. All right. Next one is, does the engineering education cluster fund different projects from the STEM education from EDU? And if so, how do they decide whether to take their project to the engineering education or say IUS in EDU?
Yeah, that's a great question. So again, it really comes down to the details of what it is you're trying to do in terms of breadth, scope, and focus. So I would recommend writing not an extensive white paper. Maybe start with a page and write to the program director in the Division of Engineering Education and Centers. You don't have to send it to multiple people. Often in the NSF, if you send it to one program director, if it is directly related to them, they'll respond to you. If not, they will point you to the person who might be best positioned to answer the question. So don't sweat trying to figure out who it should be. Just write to one program director and request that they forward your request to the appropriate person if you have not reached the right person. And we on the NSF end, we will try to get you to the right person so that you can get answers to your questions quickly.
Great. Okay. Wonderful. This person has a question about the ERI solicitation for 2024. So they're wondering if you have any insights into when we can expect release of the 2024 ERI solicitation.
I would recommend writing to the ERI program directors who are listed on the most recent publication opportunity. A lot of programs often develop follow-on solicitations, follow-on opportunities. So, the best I can say is stay tuned, but to write to the program directors who manage that specific program, and they might be able to give you more insight.
Great. Okay. And actually, there's kind of a related question about the RED, solicitation, that it only has a May, this previous May deadline, and they're asking if they'll be offered in 2024. So again, just reach out to one of the RED program officers for that information. Yeah. Okay. All right. What is the fundamental difference between the engineering and size directorates?
So the engineering directorate incorporates the traditional engineering fields like electrical engineering, chemical engineering, civil engineering, mechanical engineering, aerospace engineering. So all of these, in some shape or form, will fall into those broad divisional buckets that I described in the earlier slides. So, so think about your project and say, okay, where is the center of gravity? If it's in the computer science space, or in activities that are fundamentally derived from the world of computer science, then your center of gravity might be in the computer science directorate. Whereas if you're working on concepts that are more traditionally related to the engineering fields, the established engineering fields, your center of gravity might be in engineering. Again, don't sweat it. Write a one-pager. Don't have to write a 10-pager. Write a one-pager and describe your concept as succinctly as you possibly can, and take a guess. Send it to somebody in the engineering directorate and ask them, what might be the best fit for what it is I'm trying to do, and see what NSF has to say. Okay,
that's great advice. And the next question, I think, kind of falls into that. What advice you just gave. This person is saying that they're targeting green AI and software, and they're wondering whether they need to target that to sides, or can they also target it to engineering. And I think that, again, falls in line with, contact a program officer in size and engineering and have a conversation and get some advice that way.
Exactly. In fact, a lot of projects are multidisciplinary, transdisciplinary. I mean, they involve, you might have, electrical engineers and computer scientists all working together, or you might have mechanical engineers, electrical engineers, and computer scientists working together. So look at your team composition, look at the kinds of people you need to assemble to pull together a powerful research team, and then describe that in your white paper to NSF, so that NSF gets a holistic view of what it is you're trying to do and then can give you the best advice.
Great. All right. Okay. Somebody was asking when will the engineering NSF career workshop be, and is it free of charge?
I don't know the answer to that question really. I can find out for you. Why don't you write to me, and I'll refer it to the program directors that are closer to that space and have them respond.
I know it is free. That's for sure.
I'm assuming it should be free, but I
it should be
want to
free.
say that without
right. So and it's Balan at nsf.gov.
At nsf.gov.
Yes. Yeah. Okay. All right. Okay. So, and we had one more question. And again, I'm going to direct, it's a great question. I'm going to direct this person to also reach out to you about, they'd like to add some minority focused universities to their engineering research center. So, please reach out to Dr. Balan about that.
Yeah, and I'll definitely put you in touch with the Engineering Research Center program directors who are much closer to that program, and they should be able to give you more specific feedback on your question.
Great.
As with anything, please don't hesitate to write to NSF on, whatever it is there are no dumb questions when it comes to us. So just ask us whatever you want, and we'll try to, help you get to getting the feedback that you need so you can move forward.
Right. Okay. Well, I would like to thank everybody for joining us today. Thank you, Dr. Balan, for all of your great information. So thank you very much, everybody, for your kind attention, and we hope you have a wonderful rest of the day. Bye-bye, everybody.